The mean value theorem will come up at least once a week from here until the AP exam. So this is a very important theorem. First off, f must be continuous on a closed interval. And it must be differentiable between the endpoints. It's okay if it's not differentiable at an endpoint, but everywhere between the two endpoints it has to be differentiable, meaning we could have no cusps or vertical tangents in between the endpoints. Then there exists a number c between a and b, so a and b are x values, so you get some number c between a and b, such that f prime of c equals f of b minus f of a over b minus a. Okay, when you're still looking at that, you're probably going, what? But let's break it up. Harry? Or break it down. F prime of c represents what? Okay, the slope at c. Good. So the slope at x equals c equals, what is f of b minus f of a over b minus a? It's part of a limit formula, which is derivative, but what was the first thing you said? The S word, right. It's the slope. It's the slope between what 2 points? Yeah. So it's just the slope between x equal a and x equal b. So all that's saying is that if I have a continuous function on a closed interval, if I find the slope between my two endpoints, then there is some point in between those two endpoints whose derivative is the same as the slope between those two endpoints. So in this case, c would be about right there.
Wait, I don't understand why the lines up there are really.
You're always guaranteed one value. There is another value of c right here. Okay. So we'll call those C1 and C2. You're guaranteed at least one value of C. You could have more. Yes. Okay, read what's right below it. Geometrically speaking, the theorem guarantees the existence of a tangent line that is parallel to the secant line between the two endpoints. A secant line intersects at least 2 points on a graph. A tangent line just intersects one. So there is a tangent line that's parallel to the slope of the two endpoints. Okay, it's kind of a big theorem, but it's pretty easy and straightforward. All right, so given this function 5 minus 4 over x on the interval between 1 and 4, find the value or values of c that's guaranteed by the mean value theorem. It helps you visualize it. We're only talking about this section between 1 and 4. So the mean value theorem says that if you draw the slope between those two endpoints, then somewhere between those two endpoints, I'm going to have a tangent line that's parallel. Okay, so you'd say about 2. Let's use the equations in calculus to actually figure out what that value of c is. All right, so f prime of x, the mean value theorem basically says that f prime of x, if you want to use c, you can, but I just kind of, c is an x value, so I usually just use x. F prime of x equals the slope between the two endpoints. So that would be f of 4 minus f of 1 over what? 4 minus 1. Good. I'm going to rewrite f of x as 5 minus 4x to the negative 1. Y'all cool with that? Okay, so what's f prime? Okay, 4 over x squared or 4x to the negative 2? Either way. I'm using the mean value theorem formula right here, and I'm taking f prime of x. Okay. All right, equals f of 4 is what? 4. F of 1 is 1. All right, so 4 over x squared equals 3 over 3, which equals 1. So 4 equals x squared, and when I take the square root of both sides, I get x equals, very good, positive or negative 2. But we're only in the interval between 1 and 4, so the only value that's valid in this interval is 2. So whoever said it looks like it's exactly at x equal 2 was right. But you won't always be given the graph, and it won't always be perfect, nice numbers like that. Okay, so geometrically we talked about that the mean value theorem guarantees a tangent line that's parallel to the slope between the two endpoints. In terms of rate of change, the mean value theorem implies that there must be a point between A and B at which the instantaneous rate of change is equal to the average rate of change. Remember, instantaneous rate of change is the derivative at a specific point. The average rate of change is the slope between the two endpoints. All right, so a plane begins its takeoff at 2 p.m. on a 2,500-mile flight. The plane arrives at its destination at 7:30 p.m. Explain why there are at least 2 times during the flight when the speed of the plane is 400 miles per hour. What? Because the pilot went that fast twice. Why is he guaranteed? How can we figure out that he's guaranteed of going that fast twice? Okay. Let's start with finding the average speed. Okay, so your average speed is basically the slope between the two endpoints, or change in position over your change in time. Okay, how far did we travel? 2,500 miles. And that happened over how many hours? 5.5? What's 2,500 divided by 5.5? 454.5? Okay, so approximately 454 miles per hour. So if your average speed is 454 miles per hour, when you're taking off, I mean, do you hit 454 right when you take off? No, you've got to gain speed, and then you get to your cruising speed, and then you decrease. So if your average speed is 454 miles per hour, at some point you're probably going to be going faster than that. So why are we guaranteed of going 400 miles per hour? Yeah, as you speed up, you're going to hit 400 and go past it, and then as you go back or slow down, you're going to hit it again. Yeah. All right, we just explained it, so I'm not going to write that down. So I don't know, maybe I will. So you're going to hit 400 twice because, yeah, at least twice, because you'll hit it as you're speeding up to your cruising speed and as you're slowing down to land. I don't want to write that. I'm lazy. Okay. All right, a company introduces a new product for which the number of units sold is given by S of t equals blah, 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 where t is the time in months. I'm going to let you use your calculator on this one. Find the average rate of change of S of t over the first year. Okay, we learned average rate of change way back in section 2.2, I think. What's the formula for average rate of change? Rate of change is a fancy name for slope. We're trying to find the average slope, or the slope between the two endpoints. And between the first year, we're talking about between these 2 points. So the average rate of change would be S of 12 minus S of 0 over 12 minus 0, or just 12. Yeah, that's just the slope formula between your two endpoints. Okay, find that slope. All right, you should have gotten 64.286. What would the units be here? Yeah, units per month. All right, during what month does S prime of t equal the average value during the first year? So essentially, what are we trying to find? Or somebody write me an equation that we would... Good. S prime of t equals 64.286. Now, I didn't find the 64.286 on my calculator, so you're going to have to use that exact value on your calculator. But the easiest way to solve this would be, I'm going to make my calculator take the derivative of s, because I don't want to use the quotient rule. So under F3, I'm going to take the derivative of 200 times 5 minus 9 divided by parenthesis 2 plus x. Comma x, and close my parenthesis. I think I have all my parentheses in here. We'll see when I hit enter. Yep, sure enough. I downloaded it from TI. I think so. All right, so basically what I want to do is I want to set this equal to my 64 point something and solve that equation. So I'm going to go to solve. And I'm going to highlight that derivative and hit enter. Equals, and then what you need to do is go up and highlight your 64.286 and hit enter and bring that back down, because your final answer has to be accurate to 3 decimal places. So you can't round an answer and then use it to find another answer. I'm going to have to type in the 64.286. Yeah. If you want to do it out by hand, you can do that. And when you solve, you have to do comma x. And I'm going to hit diamond to enter because I want a decimal approximation. So 3.291, or x equals -7, is that a valid answer for this problem? No, because I'm just talking about the first year. Right, so somewhere in the 3rd month or in the middle of March. Did y'all get if you round to 3 decimals, do you have 3.291 or is it 3.292? Okay, so you can see that when I used the rounded 3 decimal to work this problem, I actually would get my final answer wrong. So you have to use your exact one. So 3.292. Yeah, so it's 3.292 months from the beginning, or from January 1st, or sometime during March. They'd probably say after how much time is the average rate of change equal to the instantaneous rate of change. There is a little kind of special case of the mean value theorem, and it actually has its own name. It's called Rolle's theorem. However, it's still the mean value theorem, so I don't really expect you to know Rolle's theorem. You can think of it as the mean value theorem. But if f is continuous on the closed interval and differentiable on the open interval, if f of A equals f of B, then there's at least one number in C such that f prime of C equals what? If f of A equals f of B, so if your two endpoints have the same y value, then you're guaranteed a value of C such that f prime of C equals 0. Okay? Okay. It's saying, okay, so you've got a continuous, closed interval function, but now we're saying that f of a equals f of b. So your two endpoints have the same y value. Well, what's the slope between the two endpoints? 0. So you're guaranteed the derivative has to equal 0 somewhere in there. And this particular one that I drew, you've got it in two different places. Okay, so it's still the mean value theorem because the slope between the two endpoints equals f prime of c, but we're just making the slope between the two endpoints 0. If it was a straight line, yeah, if it's a straight line, then the slope between the endpoints is 0, and you're guaranteed at least one value of c such that the slope is 0 and it's be everywhere. The figure shows two parts of the graph of a differentiable function on the interval -4 to 10. Explain why f must have at least one 0 between -10 and 4. Let's go back to the beginning. That's a differentiable function. If a function's differentiable, it's guaranteed to be continuous. So if this function's continuous, at the very least, I can connect those two. Now, could I have some squiggly mumbo jumbo going on in there? Absolutely, as long as it's continuous. But at the very least, I've got to be able to just continue that. All right, so why must f have at least one 0? Okay, good. What theorem is that? Okay, what she said was the y values, the start and stops have different signs. Okay, so what she's saying is that if you pick an interval here, you've got a y value that's positive and a y value that's negative, and if it's so your y values have opposite signs. So if your function's continuous, you're guaranteed a 0. It's called the intermediate value theorem. Okay, part B, explain why f prime must also have at least one 0 on the interval. And what are these zeros called? Okay, there is a maximum if you look at that. But how can I use the mean value theorem to prove that y f prime must have at least one 0? All right. Somewhere between x equals -10 and 4, there's an a and b such that f of a equals f of b. Like right here and right here. So by the mean value theorem, I'm guaranteed that f prime equals 0 because f prime of a equals f prime of b. I mean, you can look at that graph and say, well, there's a hill, so you need to have an f prime. The derivative will equal 0 at the crest of that hill. But using the mean value theorem, f prime must have, if this function's continuous, then I must have an f prime equals 0 because there do exist two numbers such that f of a and f of b are equal to each other. And the slope between two y values that have the same y value is 0. All right, C, we just did that, make a possible sketch with one 0. D, make a possible sketch with at least two zeros. Can I do two zeros? Can I do exactly two zeros? No, because if I come down and then back up, I'm going to have to go back down like that. So I could never have exactly two zeros, but I could have 3. And then part E was the condition of continuity for f and f prime necessary to do parts A and D. It kind of depends on how you look at that. Yes, and like, did I have to say that that function was continuous in order to do this problem? No, because if I told you that it was differentiable, you know it's continuous. So I didn't have to tell you that it was continuous. You inferred that it was continuous because differentiability implies continuity. Differentiable implies continuous.